This problem is asking us to find the intervals of concavity and the inflection points. Both of those are dependent upon the second derivative. So first up, we're going to need to find the second derivative in this problem, which means, of course, first finding the first derivative, and then finding the derivative of that, to then have our second derivative. All right, now that we are here, the very first thing we're going to try to find is the inflection points, because inflection points are where the second derivative equals 0. So I'm going to take my equation here, and I'm going to set it equal to 0, and then solve it out for x from there. And so I know I have a point of inflection here at x equals 1/2. Now I can work on the intervals of concavity. For those intervals of concavity, it's going to go from -infinity up to the 1/2. And the other interval of concavity is going to go from 1/2 up to infinity. Remember, it's always going to be breaking across the inflection points. In this case, one inflection point means just one break between those two intervals. All right, so now I need to know, is it concave up or concave down within each of those? In order to find that out, I'm going to test a point from within each of those intervals. So for this first interval then, I'm going to choose to use 0 because that's a nice easy point that's inside that interval. Now when I test that, make sure that you're thinking about what are you plugging it into to test it here. In this case, because I'm trying to figure out what the concavity is, it tells me to be plugging it into the second derivative equation. And so if I plug 0 into the second derivative here, that gives me a positive 6. All I really care about is the fact, though, that that's positive, which means that this is concave up. All right, and then we're going to repeat the same process for the second interval. Just I need a number from within that interval that's nice and easy to work with. I think 1 is a good candidate there. So I'm going to figure out what f double prime of 1 actually equals, and that happens to give me -6. But of course, again, all I care about is the fact that it's negative, which means that that one is concave down.